Hi guys, today we are on lesson 15 in module 1 of Engage New York. Our objective today is to divide decimals using place value understanding, including remainders in the smallest unit. So we're going to talk a little bit about in 4th grade how we would write remainder 1, remainder 2, and how in 5th grade, now because we know how to unbundle numbers and cache in numbers for smaller units, we're going to be able to do away with remainders and show our answers as decimals. In our first problem, we have 1.7 divided by 2. Now, you would probably also be able to call this number, if you understand place value, 17 tenths. 1 and 7 tenths is 17 tenths. And we're going to be breaking that into 2. But first, what I'd like you to do is think about 17 tenths. And what is half of 17 tenths? Because dividing by 2 is cutting it in half. 17 is an odd number, which means you can't have two equal groups. I can see that I'll be able to make two groups with something left over, and that's what we're going to take a look at first. Okay, I've modeled 17 tenths, or 1 and 7 tenths, on the board right here. I've got my 1 and my 7 tenths. Now I'm dividing it into two groups. So what I've done is I've drawn two rows at the bottom. Here's row 1, here's row 2, and these two rows will have the same number in them because these are the two equal groups that I'm breaking up 1.7 into. Now, when we start with our ones place, we have to think about how many groups we can break 1 up into. Can I break 1 into two groups? Not without breaking it apart, which is what we're going to do. So I'm going to take my 1, and I'm going to cache this 1 in for 10 tenths, because 10 tenths is equal to 1 whole. So I'm going to take my 1, I'm going to cache it in, I'm going to go to the bank, and I'm going to get 10 tenths. Okay? So let's put our 10 tenths in our tenths column. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. These magnets are crazy. They want to stick to each other. I've added 10 tenths to where I already had 7 tenths. So we have 17 tenths here, and we were calling it 17 tenths even before this. Back in the day, we were calling this 17 tenths before anybody else was. But because I now have 17 tenths, I can group those into two equal groups. Let's see how many equal groups. Let's see how many tenths will be in two equal groups. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So let's show on our standard algorithm first what we've done, and then we'll talk about the 1/10 we have left over. Initially, I asked how many groups of 2 I could get out of 1, and I can't get any groups of 2 if I only have 1. So I put a 0 there. Now, I'm going to put a decimal point up in my quotient. We always put the decimal point directly above, but the reason is this is my ones place, and the decimal point goes to the right of the ones. Now I'm looking at 17 tenths, which is what we had over here, 17 tenths. And how many groups can I make out of 17 tenths if I'm cutting it into two groups? How many will be in each group? Well, we've showed that we can have 8 tenths in each of two groups, which gives us 16 tenths. Now, here's the reason why we subtract. I was able to use 16 of my 17 tenths, and I'm proving it here by showing with subtraction that I have 1/10 left over. Now, in 4th grade, we would have written remainder 1, but we don't write remainder 1 anymore in 5th grade, because with age comes responsibility. What I'm going to do now is I'm going to add a 0 in my hundredths place. So rather than having 1/10, I'm going to have 10 hundredths. Now let's look at that on the place value chart. This tenth, we know, is equal to 10 of the unit to the right, so I'm going to cash in my tenth for 10 hundredths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now I have 10 hundredths, and I think I can make two equal groups out of 10 hundredths. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I've put 5 in each of those two groups, 5 hundredths in each of those two groups. And what I'm going to do is show that 5 hundredths times 2 is 10 hundredths. So I've used up all 10 hundredths that I created by calling this 1/10 10 hundredths. I've used all of them, and now I don't have a remainder. I've resolved the division problem without needing a remainder. All right, and I did that by breaking up that tenth into 10 units of hundredths. Okay, let's try one more. The next problem is a whole number problem, and it's called 17 divided by 4. So let's write 17 divided by 4. And let's model that on our place value chart. 17 divided by 4 is going to have a 7 in the ones place and a 1 in the tens place. 1/10, 1, 2, 3, 4, 5, 6, 7. So I've got 7 ones and I've got 1/10. Now, in order to break this into 4 groups, I'm going to need 4 rows at the bottom. Okay. As in the first problem, if I have 1, 1/10, can I break 1 into 4 groups? Not without unbundling. If I have 1 cupcake, I cannot make a group of 4. So I put a 0 there. Now I'm going to look at 17 ones, okay? Rather than calling it 1/10 and 7 ones, now I'm looking at 17 ones. Can I make 4 groups out of 17? Yeah, I can make 4 groups because I know that 4 times 4 is 16. So let's show that. And what we've actually done is we've taken that 10 and cashed it in for 10 ones. So let's show that. Here's the 10, and I'm cashing it in for 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's see what we've got here. We've got 17 ones, and we decided we could break them into 4 equal groups of 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So as you see, I have 4 ones in each of those 4 groups, but I'm left with 1 group of ones. And now I'm going to have to break that 1 up in order to resolve this without having a remainder. So in order to do that, I take my dry erase marker and I say, okay, I'm going to cash this 1 in, this 1 that I have left. Now I know my decimal point is after any whole number because that's the ones place and my decimal is always to the right of the ones place. I can add a 0 here without changing the value. 17 and 0/10 is the same as 17. And I could also call this 170 tenths or 17 ones and 0 tenths. I'm going to bring this 0 down, which really means what I'm doing is taking this 1 and breaking it into 10 tenths. So that's what I'll do here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I'm saying to myself, can I make that group of 10 into 4 equal groups? Well, let's see. 1, 2, 3, 4, 5, 6, 7, 8. Oh man, I can't make another group here. I can't add these 2 to these 4 groups. I only have 2. But what I did do is make 2 tenths in each of my 4 groups. 2 times 4 is 8. I used 8 of my tenths, and I have 2 remaining. Now we brought down that 0 so that we'd be able to break and unbundle the number, and I can add another 0 without changing the value of my dividend. I'm just adding a 0 so that I can bring it down and represent those 2 tenths as 20 hundredths. Now, I ran out of markers, of little place value discs, so I'm going to call this 10 hundredths and 10 hundredths. Remember, 1 tenth is equal to 10 hundredths. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's this one. And this one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Can I break these 20 hundredths into 4 equal groups? I sure can, because I know that 20 divided by 4 is 5. And I'll prove that to you because I have 5, 5, 5, and 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That uses all my hundredths. I'm taking the 20 hundredths I had away from the 20 away from the 20 hundredths I have, leave me with nothing. How many groups? How many were in each group? 5. 5 hundredths times 4 groups is 20 hundredths. I used all of them. And let's see if my place value chart models the same quotient that I got in my standard algorithm. This is 1, 2, 3, 4 ones, 2 tenths, and 5 hundredths. Now, 4.25, 4.25. And you'd find, if you wanted to check you were right, if you multiply your quotient, 4.25, times the number of groups, you'll get the original number you started with, 17.